Hi there, welcome to the Strayos tutorial on Muckpile AI. This module creates an automated set of cross-sections through the Muckpile and automatically measures distances like center of mass movement, average throw, to give you an overall assessment of your heave and Muckpile shape. So to start, I'm going to bring us to the pre-blast design. So you want to make sure that you have a pre-blast shot design on a pre-blast flight of the bench. And the important thing here is to make sure that your back row is in the right position, because it's the back row of holes that is used to generate the cross sections. You'll also want to make sure that your shot volume is calculating correctly. So good to visualize that and make sure that that's all the boundaries are going right to the toe, because this volume here is going to be used in our swell factor calculation. So once you've got your pre-blast shot design all done, you're going to go out, you're going to load and fire the shot. Afterwards, you're going to fly out with the drone and take a set of nadir photos, so just photos looking straight down in a pattern over the top of the Muckpile. It's good to use autopilot for this. It's a pretty simple flight plan. And then what you're going to do is you're going to come up and create a new project to upload those pictures and enter all of the details. The thing to check though, to make sure that you do is to switch on the post-blast fragmentation and Muckpile AI toggle here. So this is really important because this is what links it to the pre-blast design, and it needs to have this link in order to match up the volumes before and afterwards, match up the profiles before and afterwards. So you're going to switch this one on. You don't need the high wall AI for this one, and make sure you toggle this one on and link it. So I've already processed one, so I can jump into it here. This is the post-blast project. As you can see, we have the Muckpile, 3D model of the Muckpile here. And if I go into my blast performance folder, I can go to Muckpile AI. This is the module that we're going to be looking at. So the first thing to do is to go into the Muckpile AI module and to check if the elevations of the pre-blast and the post-blast model are synchronized with each other. So what can happen is, if I switch this on, you'll see these elevations are not synchronized. So everything else in that X and Y dimension is synchronized. So this would happen if you just used a standard off-the-shelf drone like a regular Phantom or Mavic to fly both the pre-blast and the post-blast Muckpile. If you don't use GCPs and you don't use PPK processing, then everything should generally be pretty much in sync in this 2D view. But when you start looking at elevation, you may find that there's a difference. So really what you should do is, if you're using a standard off-the-shelf drone without GCPs or PPK, is you should always calibrate the elevations before using this Muckpile module. So the way to do that is to come up to the coordinates marker here. Actually, we'll do it in our pre-blast one. And so basically what we're going to do is we're going to drop a point, and we're going to bring that point through to our other post-blast model, and then we're going to calibrate the elevation to the pre-blast model. So a bigger point right behind the back of the shot, right here. Doesn't matter about the name. And I'll have a look here and see that this is 539.35 feet. Now what I can do is go find this in annotation and layers, in annotations, and I can copy to another project, find my site, find my post-blast project, click copy, confirm, and it's copied successfully. And from here, so remember that number 539.35, I'm going to go to my post-blast project, and you can see here it's got the elevation at a different number. So what we're going to do is now click calibrate elevation, zoom right in, and we're going to go 539.35, hit save, and it's going to basically shift the entire model up or down to match that elevation. So this is a pretty handy thing to use in these kind of situations, because it means that you can get an accurate Muckpile assessment without having to use ground control points. So now I'm just going to switch off this annotation, and I'll go back to Muckpile AI, and once this loads, I'll switch on the shot design, and you can see now that it's all synchronized. So you should only have to do this if you've not used ground control points. If you use ground control points or anything like that, it should just sync up from the beginning. So the next thing that you do is turn on the Muckpile that it's detected. So it automatically detects the Muckpiles. If there are potentially multiple Muckpiles in this list, it'll put the one that thinks is the best one at the top. So start with the top one. What you can then do first of all is check the auto detected Muckpile boundary and see if you have to make any corrections. So over here, I might just adjust this corner. To make that line up, yep. So that's all good. The next thing that I want to do with this Muckpile is just make sure I set the bottom plane that it's using to the lowest. To my floor plane. So actually, let me click done on correcting the Muckpile boundaries. And then I will go and check where my floor plane is, where I designed my holes to, and then set that as my bottom plane for the Muckpile. All right, so let me go back to the pre-blast design. And I'll come into the drilling design module. This is the easiest way to find it. And I'll click on my hole here. And now the easiest way to find it is to just remember when you set up the pattern what you designed it to, and how much subdrill you used. Another way, if you have lost that number, You can find the toe elevation here and then add the subdrill back onto that. Or you can also find it in the burden report. So if I generate a quick burden report, I'll show you where it's shown. And this is just a trick for finding that number. There we go. So basically just come down to any of these and check the floor elevation here. So 491.2. So now if I go back to my post-blast project, in my Muckpile AI module, I'm just going to set this. It was almost on the money already, so it's 491.2, and then hit update. And that's just going to help give us a more accurate measurement of the volume comparisons. So in this case, I've got my my results, I guess, my summary results shown here straight away. For the pre-blast volume, which it's pulled from that drilling design, from the pre-blast shot design. And then I've got my post-blast volume, which it's calculated based on this Muckpile boundary that it's set here. And then it's got some other metrics down here on average center of mass movement, average throw, maximum throw, and trough drop. So to demonstrate those, I'll show you how to launch the graph. So you come to the Muckpile movement bar here. And then the easiest way to do it is to pop it out so it's bigger. I know that there was a bit of muck in front of the face on the pre-blast shot over here, so instead of looking at one, I'm going to look at one up this end, maybe hole 18. And so here's a good way to visualize this. So basically what it does is for each back row hole, you can select from the list that hole, and it has a cross section generated that goes straight through the Muckpile, and it shows you with this orange line where that cross section is. Now it takes that cross section and then does a series of calculations. So it looks for things like firstly the trough drop. So you can see that's where the distance, that's the maximum distance between the pre-blast profile and the post-blast profile. So really looking at the depth of the power trough. The green line here is just the hole, showing you where the hole was. The center of mass movement is basically the centroid of the area of the pre-blast shot to the centroid of the area of the Muckpile. So what that does is it tells you how far you've moved kind of the centroid, so most of the material. So it's a good one to look at if you're trying to generate a lot of heave. And then finally what you can do, so over at the side here, these numbers are just the averages and the aggregations of all those. Average throw and maximum throw are calculated from where the hole is, so from the back of the shot. So the average throw is the horizontal distance from here to where the center of mass ended up, and the maximum throw is the distance, basically the length of this orange line, so the distance from the back of the shot to the front of the Muckpile. So those are all of the measurements that get done. There's also a cast analysis option that you can switch on. And so what this does is it basically projects a line up from the toe that it detects up through the shot, and it calculates what percentage of the Muckpile is past that line, and that's the cast percentage. So it works that out, and it works out your cast volume and your non-cast volume. So this can be handy if you're in a coal mine situation. For example, I'm trying to work out how much material has been cast to the final position. So finally, once you've got all of these numbers calculated in Straos here, you can export this using the Muckpile movement report, where you can basically just click the download button. It'll generate the report, and it'll give you profiles for all of the cross sections, as well as a summary view of the shot. So as you can see here, we have all the summary, we have the sections drawn on the map, and then we have the individual ones for each hole. Awesome. So thanks for listening, and I will see you in the next video.